This is Cindy. 3D modeling is widely used in the media, gaming, and education industries. The global market size of 3D modeling and animation has reached $6 billion. In the past year, using AI to create 3D models has gained much attention and many Gen AI companies emerged. I led the research team of several PhDs, finished the prototype, and also talked to quite a few game studios and artists. In this video, I'm gonna unfold the technical paths and share my views of the AI 3D space as a researcher and a founder. First, what is a 3D asset? What is it composed of? Mesh is a collection of vertices, edges, and faces that define the shape of a 3D object. Texture is an image applied to the surface of a mesh to give it color, pattern, or surface detail. UV mapping is the process of projecting a 2D texture onto a 3D mesh, which allows the 2D texture to align with the 3D surface correctly. In addition to these components, 3D modeling encompasses materials, normals, rigging, and animation. A common 3D asset, such as a house or a tree, can take an experienced artist several days to make. That's why many founders seek AI-based solutions. Ever since the last decade, researchers have been looking for methods to assist 3D creation. Inspired by the AI works on 2D generation, many early attempts for 3D generation adopted GAN. 3D GAN proposed to generate 3D objects from a probabilistic space. Similarly, when contrastive language image pre-training CLIP was proposed for joint embedding in 2021, the CLIP-based works on 2D generation naturally inspired explorations in 3D. Then, Dreamfield proposed a text-guided 3D generation using a neural radiance field, NeRF, which is an inverse rendering approach to create 3D models from a set of 2D images. In 2022, Dream Fusion first proposed using a pre-trained 2D text-to-image model for text-guided 3D generation through differentiable rendering. Their core method, score distillation sampling (SDS), samples uniformly in the parameter space from pre-trained diffusion models to obtain gradients that match given text prompts. One of the most influential papers in AI 3D, Dream Fusion inspired many SDS-based improvements. Magic 3D further improved the quality and the speed of 3D modeling by a two-step approach. Fantasia 3D disentangles geometry and appearance generation supervised by the SDS loss. My research team proposed Euclid Dreamer. For the training loop with SDS loss, depth information is taken into account in addition to the color information. Through the experiments and the user study, we have proved that adding stereo diffusion depth conditioning to the SDS training can greatly improve the quality and speed of 3D texturing. Let's look at the current state of AI 3D and share some insights that are usually surprising to folks outside of the 3D and related industries. From a market perspective, the biggest market for AI 3D, in my opinion, is gaming. In 2022, the global gaming industry's revenue was approximately $200 billion. As 3D modeling occupies a considerable portion of game development, the estimate of the global market size for the production of 3D game assets is over $10 billion. In contrast, other industries are either too small, like filming with only 30B to address, or rely on 2D formats, like architectural visualization. In the context of AI applications in 3D creation, there were technical gaps between academia and industry. Today, the majority of the research works in 3D generation focuses on generating 3D models end-to-end, meshes plus textures. AI still struggles to generate clean topology, and many tasks require an understanding of 3D objects, making the end product useless and hard to further edit by humans. AI texturing alone without generating mesh and UV maps seems a more achievable goal in terms of commercialization. Moreover, instead of generating 3D models purely from text prompts, gaming companies show a preference for converting images to 3D models. This is because they can utilize concept art, visual representations of characters, scenes, or objects as direct input for creating detailed 3D models. On top of that, art style is important too. Game studios hope to get all 3D models in the product in the same art styles. Game companies pay crazily high amount of money to customize 3D models, despite abundant choices on marketplaces like Unity Store or Sketchfab. From a technical perspective, we can use LoRa, fine-tuning, or prompting for a consistent art style. Today's AI texturing still suffer from common issues like light reflections and shadows, wrong semantics, view inconsistency, and bad color tones. Let's unfold the technical challenges. The first is data. 3D modeling data is scarce by its nature. Open source datasets like Observerse and ShapeNet contain a lot of bad quality data. In my opinion, scanned models are bad for training too because their structures and colors are not clean. Handmade stylized 3D models, on the other hand, are owned by private companies as their core art assets. Even if the companies agree to use them as training data, the quantity of tens of thousands is still too few. Data scarcity puts pressure on algorithms to use existing datasets efficiently. Startups are divided into two camps based on their tech approaches. Some utilize large 2D diffusion models like Stable Diffusion, adopting a pipeline that leverages 2D views to 3D models, while others want to base both training and inference on 3D data. The latter should yield better results, but only with a large amount of data, which I estimate to be more than 100K high-quality objects. Third is inference time. Right now, an object can take 10 to 20 minutes to generate, depending on the mesh and the GPU. For commercial products, it's crucial to reduce the wait time to under 1 minute for end users. My team estimates that the inference time will be cut to very short, say 10 seconds, in 2 years with more efficient algorithms. Next, let's take a look at the market landscape. Current active startups include Vast, Meshi, Luma, and CSM, and so on. Vast believes in 3D foundation models and incorporates much unique 3D data for training. Despite that the texture generation is still far from using in my games, the triple model is one of the best I've known after trying a bunch. Meshi aims to empower game studios and has an active community of talented individuals. The team executed everything so well and had many insights. Luma allows people to scan objects using their smartphones and remix objects, which raised 43 million and is leveraging a compute cluster of about 3,000 NVIDIA A100 GPUs. It's kinda cool that you can use the app to scan the surroundings and save moments in 3D. The super resourceful team doesn't have plans to tailor products specific to gaming. CSM is said to be good at mesh generation, potentially for 3D printing and gaming. They were founded in 2020 and have raised 10 million from VCs. Major projects by leading tech companies. OpenAI's Shape-E, I think, was trained from mostly scanned data and is only used by a few. NVIDIA Picasso is still super early in the lab. There have been many startups in the past 1 or 2 years that pivoted from the AI 3D space, with Poly initially built AI tools for texture patterns, which is slightly different and easier than making textures. Backed by Y Combinator, they pivoted last year into smart cloud storage. Scenario started with AI 3D and pivoted to generating 2D assets and other components for games. Gemo AI started with AI 3D too, funded by top researchers in AI 3D and later shifted focus to text-to-video generation. So why AI 3D startups struggle? It's almost a consensus among the startups community that AI 3D's tech is not ready yet to generate ready-to-use 3D assets. If we back up a little bit, would it be possible to build a co-pilot? That is, if AI can finish 80% of the work and we have human labor to complete the remaining 20%? Unfortunately, the answer is no. AI-generated 3D models are too rough and it takes even more time to fix them than just making a new one from scratch manually. From my own experience with Euclid AI, it is possible to use AI for 3D models useful at the brainstorming stage or the marketing stage of a game. If game studios want some fast prototypes for some ideas or some assets in various art styles for quick A/B tests in their ads, then AI can help them fast and cheap. However, companies won't be willing to pay a lot for these. Are there some hacks or stupid methods that can work? Sloyd AI is an example of retrieving relevant 3D models and altering their appearances through parameters. KDM's 3D is another example, at least at some point, that used pure human labor to generate 3D assets while claiming that they were generated by AI. Now it states to use both humans and AI to ship 3D models within 20 minutes at an affordable cost and just closed a round of 15 million. Besides B2B, how's AI 3D in the consumer market? It would be cool to create and interact with 3D scenes and objects through VR devices. 2024 was expected to be a big year for VR and AR, as Apple was to launch Vision Pro in early February. However, within 2 weeks after the launch, stores are seeing conversion rates as high as 10% to 15% after demos, as reported by Bloomberg. In my opinion, the ultimate killer is yet to come, which is the technology of text-to-video generation. A few weeks ago, OpenAI announced the video generation model Sora, which achieves amazing 3D consistency or consistent geometry and color of an object from different camera angles. If we recall the process of generating 3D assets from multi-views, then we know that video generation models will eventually be able to create 3D assets, and that day is likely to come sooner than later. In the end, I'd like to share 2 points regarding the evolving landscape of 3D AI. Firstly, despite the impressive capabilities of AI algorithms, it's crucial to recognize that AI will not replace human creativity. The depth and nuance of human artistic expression derived from our experiences and emotions remain unique to humans. Secondly, for startups navigating this innovative domain, the emphasis should be on achieving product market fit rather than solely focusing on technological novelty. Success in this field hinges on creating solutions that resonate with market demands. Thank you so much for listening. See you next time.